Challenger.
Welcome, guys and gals. This is your host, Frog Prince Rana, and thank you for dropping by. In this video, I'll try to recreate an experiment flat earthers often try, and that is to show things disappear from bottom up, even on a flat surface. This is to be an explanation why boats going over the horizon disappears bottom up. At least this is different than blaming refraction. Yes, I know. We will look at a channel called Richie 00000. Now, between those who reads Zetetic Astrology and repeats the same talking point and those who actually tries some experiment, well, I prefer those who at least tries. So the format of my video, first we will go through Richie's video and her conclusion. Then I will be addressing Richie and point out some issues with her experiment. Finally, I'll try the same thing myself. Let's jump in.
So, if I put this, obviously we can see the coins. If I lower it in elevation onto the game face, you can see I'm on the game face. You can see the blue edge of the game face, but we cannot see all the coins. They have disappeared.
I will admit, after rescuing damsel in distress from dungeons all my life, I am softer on opposite gender most of the time. This is definitely one of those times. So Richie, there are some problems with your experiment. Now my take on this comes from my little experience with photography. But none of what I am about to say is my opinion. These are actual facts. First is the equipment. Every lens suffers from distortion. Even a highly precise, super expensive lens would have a minute distortion nevertheless. Now cameras are sophisticated, and the software inside can correct these distortions if the lens is supported. For example, my camera has 3 such compensation options. Obviously, the main one is distortion of the lens, followed by compensation for shaded corners, and finally, compensation for color deviation at the corners. I'm not sure if the phone you're using has such correction. In any case, this distortion is minimal at the center line. So for any such experiment, including boat going over the horizon or Isle of Man from Winter Hill, please try to keep the horizon or vanishing point at the center of the lens. Next issue is zoom. There are 2 types of zoom, optical and digital. In an optical zoom, as you can see on the screen, when zooming in, the glasses inside the lens physically move. You can see how much wider this lens physically got when moved from 100mm to 200mm. Whereas a digital zoom, well, suppose based on the camera's sensor, distance and such, a 2-pound coin takes up 100 pixel by 100 pixel area. This is the data the sensor or photo has. When you zoom in by, say, 2x, well, you're asking the system to show you that same coin at 200 pixel by 200 pixel. Remember that the data is not there. There are several algorithms available, and in all essence, tries to figure out what color those missing pixels should be. One common method is nearest neighbors, and it is exactly what it sounds like. For a missing pixel, we look at the colors of all pixels around it and try to figure out what it should be. Basically, whenever you use digital zoom, you introduce pixels that may not be correct. I agree that unevenness should not matter. We normally don't have completely flat surface around us. Even glass table may appear flat to us, but it still has imperfection. Just not enough for us to detect it with naked eyes. There is a big but though. It doesn't matter only when our eye level or camera position hasn't changed. If I were you, I would get a tripod to make sure the camera is still. Now, the major issue with your experiment, and to explain why you got that particular effect. Of course, you'd agree that thickness of our 2-pence coin is lot less than its diameter. Well, the copper-plated one have a thickness of 2.03 mm, where the diameter is 25.9 mm. So even if you stack 5 2-pence coin on top of each other, you're coming to a 10.15 mm, which is still less than half the diameter. In your case, you have the coins lying flat. On screen, you can see two illustrations. One is what you're seeing from a higher elevation, and the other one from the same level as the coins. Do you see how the angular size or the angle a coin to the viewpoint is different in both cases? That angle has to be larger than minimum resolvable angle by the optics in question. May it be our eyes or a camera. I have talked about this in way too many videos. Link in description. Simply put, when that angle is too small, we can't resolve it or see it. As you're moving your camera down, that angle is getting smaller. If you had your coin resting on its edge, you see that in my test, you'd get a bit better result. The angle may still change a tiny bit depending on if you're seeing the coin edge or not. I'm sure you'll have the same result even with a 1 penny. That is all. Now let's quickly run through my setup. I wanted to have a 2-pound coin on a plane, and that plane should extend all the way to the camera. So I can't use any part of my floor, as I don't have a cavity to lower the camera to bring the floor to center of lens. I can't lift up my coin with a book or similar, as then that plane the coin is resting on does not extend to my camera. The best I could do at home is this L-shaped banister. It is around 10 feet length in the side I would be using. For the gear, I have my cheap Sony a58 with a 42mm to 105mm lens. To minimize any movement, I used a tripod and a remote shutter. This is to ensure that I don't shake the camera when pressing the shutter button. The camera only does 20 megapixel. The photo resolution is 5456 by 3632 pixel. This video that you're watching is 1080p or 1920 by 1080 pixel. Furthermore, you might be seeing this picture in my boob tube, which is even smaller. So, to fit the whole photo, I do have to shrink it. In reverse to digital zoom, digital shrink gets rid of pixels. But once you have seen the full photo, for the remaining, I have used a cropped version without any scaling. Even in this small scale, look what is happening. My banister is not particularly shiny. Neither is it matte. It is typical wooden banister in UK. Note how we have a reflection of the coin on the plane. Even the background is reflected. Finally, we can see the light reflection on the other leg. And as the edge of the banister is curved, it creates this hazy looking light reflection. Next is the same setup but with minimum light. I just want enough to illuminate my coin and not enough for background reflection and such. After leaving the safety of my house during this pandemic, I went to my nearest park. I live in Yorkshire and it is pretty hilly. And footpath is not really designed to be completely flat, and not with that compound. But you can see the same result. Some additional details are also on screen. So what is the result of my experiment? Well, first of all, it is a very localized test. There is not enough distance for atmospheric refraction to come into play. And the result is exactly what I have expected. I do have multiple videos talking about viewing angle, distance, and how items appears to us. Links in description. On one video, I stuck 2 pieces of electric tape on a lamppost and took various shots of it from distance. And as expected, though those 2 tapes were getting smaller, both were getting smaller by the same scale, and the full tape were visible all the time without any part being hidden. So yes, things do not disappear from bottom up on a flat plane. We understand that from mathematics, and until the channel is large enough for me to go and do the same test at some salt lake or something, this is what I can show. This is where I'll end this video. Thank you so much for watching and for sticking around till the end. I do hope you have enjoyed it enough to give it a like, comment, and maybe even share it with friends and families. Being a small channel, I do appreciate your help. If you could also subscribe, that would be absolutely fantastic. Thank you. Wherever you are, have a safe day. Signing off.